Okay, so I'm going to go through my differential item functioning, and I'll start by talking about what it is, and then about the data that I have, and then running through it in R. So differential item functioning, which I'm going to refer to here on out as DIF or DIF, is the degree to which an item functions differently for different groups of people. This can be on the basis of anything that shouldn't contribute or shouldn't have to do with ability, such as race, gender, things like that. It's calculated based on item responses and assumes equal ability across respondents. Item functioning is intended to be invariant with respect to irrelevant aspects of the test takers, like what I just said. So this is gender, ethnicity, could be like socioeconomic status. Excuse me. DIF investigates the items in a test one at a time for signs of interactions with sample characteristics. In the widely used Mantel-Hansel procedure, which I'm going to refer to here on out as MH, and I'm going to demonstrate it here, reference and focal groups are identified which differ in a discernible way. These groups are stratified into matching ability levels, and their relative performance on each item is quantified. The ability levels are usually determined by the total scores on the test. In this way, the DIF analysis for one item is as independent as possible of the DIF analysis of the other items. The MH method is very popular in the DIF framework. It aims at testing whether there is an association between group membership and item response, conditionally upon the total test score or sum score. An item is classified as DIF if the MH statistic value is larger than a critical value based on the asymptotic null distribution, which is the chi-square distribution. So in summary, DIF is present when individuals from different groups, such as gender or ethnicity, with the same ability or skill level, have a different probability of giving a certain response to an item on a measurement instrument. DIF items can lead to biased measurement of ability because the measurement is affected by so-called nuisance factors. The presence of DIF jeopardizes the ideal of a correct measurement procedure. So that's why it's important to investigate this. The framework for describing the DIF detection methods to select from consists of 4 dimensions: the number of focal groups, the so-called methodological approach, this is IRT based or non-IRT based, the type of DIF effect being uniform or non-uniform, and whether or not the item purification is used. If this difference between the transform probabilities is independent of the common ability value, then the DIF effect is said to be uniform. But on the other hand, if the difference in success probabilities is not constant across the ability levels but depends on it, then it's non-uniform. And item purification refers to the iterative elimination of the DIF items. So about the data. The data is from a test given to applicants who are applying for the Police Cadet Academy. There are 316 applicants and 24 items. All the items pertain to spatial orientation ability, which is an important ability for police to have to be successful at their jobs. This was determined by job analysis. The data are binary, and gender is the final column, which will be used as the grouping variable. 0 is for women, and 1 is for men. So here are those. Okay, so now we can run the analysis. The library packages up here. DIF R is the main function used. LTM is used to fit the parameter estimates, and LME4 is for fitting a 1 PL model as a general linear mixed model. And then the DIF R is going to allow us to compare several different methods of DIF so that we can see across the methods which items are functioning differently. I'll go over that in a minute, but okay. So the DIF MH function is what we use to analyze with the Mantel-Hansel method. The data function is just specifying the data set. The focal name equals 1 is going to specify the code for gender male in the data because I coded them 1. So this is going to be the focal group. Group is to specify who belongs to which group in the data set. And then NR iter is how many iterations you want it to go through for item purification, like the max number. The MH method of differential item functioning identification is used here. P levels of 0.05 are used, and this is the default, so you don't have to specify that. Okay, so the first sentence of the output tells us that the MH method is the one being used. It then tells us that after 6 iterations, there was a convergence. So this is where the purification process stops, and that's when there are only slight changes in the successive iterations. So between 6 and 7, there wasn't much change, for example. So it stopped there. The chi-square statistics table is going to tell us which items have significant p-values or differential item functioning. Then you can scroll down and find which items were always classified as DIF items across the iterations and purification process. The rest of the output shows the MH chi-square statistic values that were obtained in the last step of the purification process, where DIF items are thrown out from the computation. The corresponding p-values are also given with significance levels indicated by asterisks. Sorry, I can't say that word. Asterisks. It's so hard for me. I don't know why. So you can easily identify items that are detected as being as differentially functioning by looking at the number of asterisks next to the items. The item codes are presented above this table. The detection threshold right here tells us that it tells us what chi-square value is the cutoff for significance at the 0.05 level. So, for example, we see that the S2 spatial 5 item right here, right here, has 3 asterisks and has a chi-square value of 11.9436. So if you scroll down right here and you look at the significance codes and the detection threshold, obviously 11 is much larger than 3.84. So this is telling us that it has a large differential item functioning effect. So items with no asterisks indicate that they are functioning the same way across groups and that DIF is not an issue. So all of these items here have been flagged as potentially being issues. And then the last part of the output with these ABCs has the effect sizes with 3 different categories represented by the letters, which are placed next to respective items. The alpha MH column is the MH common odds ratio estimates, and the delta MH column has the effect sizes. The classification cutoff values are given, and you can see that many items have moderate or large DIF effects. So if we go down here and look at this, this will tell us the cutoff values. So for instance, for an item to have a negligible DIF effect, the cutoff value for letter A is 0. For B or a moderate effect, it's 1.0, and then for C or a large effect, it's 1.5. So let's look at S2 spatial 6, this item right here. It has an A next to it, which indicates that it has a negligible DIF effect. So this item is probably fine as far as DIF goes. It's not functioning differently across groups. The delta MH column, which has the effect sizes for the items, says that this item has an effect size of 0.954. So because this value is larger than 0, but under 1, it is not a problem item. But then you take an item such as S3 spatial 14. Oh, 4, I'm sorry, not 14. This one right here. It has a large effect size, and it's a problem because its effect size is much larger. It's larger than the cutoff value, and that one's going to be a large effect. This one and this one are big problems. This one, I don't have any that have, or I only have a couple that have moderate effects, excuse me. So moving on, the results of this analysis can also be displayed graphically with the next part of the syntax. The res.mh is a variable that you make that saves MH results into a variable. The data is specified as DIF data because that's the data that I'm using. MH is referring to the method. Group is the group for comparison, which is gender, and that's what the variable is called in the data set. And then the focal name is 1, means that the focal group is being determined as males, and then the plot command is used to plot those results. So here we have a pretty good idea of what this actually looks like. So the plot has the MH statistics here on the y-axis and the detection thresholds for the items here. So it basically shows us visually which items are an issue. So we can see that these items are marked in red. This item right here is borderline. These items correspond to how they're laid out in the data. So that's how you figure out which item is which, since the actual variable names aren't showing up. So items like this, 6 and 8, that are, almost borderline, probably want to look into that more, and what we're going to do next, it will help that a lot. Moving on, the DIF command can compare different methods of DIF detection. So here we can compare MH, standardization, logistic regression, Lord's test, and Raju's method. The first two methods focus on uniform DIF, and the last two have a 1-parameter logistic model fitted to them. A 0.05 significance level is the default, and the as far as the syntax goes, the DIF command is going to compare the DIF methods. This is specifying the data. Again, this is specifying the group to be compared, which is gender. This is specifying that males are the comparison group, or the focal group. And then this is going to save the names of those methods that I mentioned. This specifies that we want a 1-parameter logistic model. This specifies that we do want purification, and this specifies that we want no more than 20 iterations. All right, so here we have an output. Starts right here. The first part of the output has the names of the methods that we're comparing right here. You can also see the significance levels and item response model here. A summary table is shown for item purification since it was included in the syntax. The first row of this table is going to tell you whether the iterative process converged. So yes, 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 yes. And then this is going to tell you how many iterations it took to purify. So with MH, it took the most. With standardization, second most. And with these other three, it only did 2 iterations. The summary of table of items detected for DIF is shown here. Then you can also see how many methods identified that item as being a DIF. So here we can see that the, let's see, this S2 spatial 3 was identified as being DIF across all of the methods. This one was also identified as being DIF. There are several that were identified as being DIF across all of the methods. We have a couple that only 2 methods identify them as DIF. So as the researcher, you would need to look into this further to make a judgment call. And what this is basically telling us is that most of the methods are converging or producing similar results, with the exception of just a few methods that disagree for a couple of items. So this is telling you that the methods, mostly came to the same conclusion. So you have this one that, isn't a problem, and then this one that might be. So yeah, you would have to look into that more, but that's all I got for DIF. Over.